is we are doing taking the data, raw data, to useful data that will be helpful to the insights of company, how they can take decisions and all. That is responsibility of Azure Data Engineering, taking raw data to useful data. That is single line for what is the role and responsibilities for Azure Data Engineering. So going to the today's agenda, I will cover today what is data and why it is required. So really it is required or not. Then we can go through on data evaluation and because of big data, what is the problems we arises and how we can solve it, and then we can go with the big data, how cloud supports big data, and then I will tell about Azure Data Engineering content, how it is helpful for this data role, and then Q&A session will be happened. You can ask any questions and doubts. We will be clarify here, and yeah. So now we can start. First, data. Please tell me, any one of you, what is data?
Information of data, collection
Okay.
of information.
Okay. Anyone? Anything about data? What is data? Okay. So data is nothing but it's like a, what we call it, facts, collection of facts. Collection of facts. What is meant by facts? Anyone? Any idea? Facts is nothing but we have numeric, alphanumeric, or symbols, or anything. Example like 12 is a number, and you can say something bike, or you can say anything. It is a data. So you can use symbols. These symbols, anything is a fact. So data is nothing but collection of facts. This fact is nothing but anything we used in real time. So now, anyone know how many types of data are there? Can anyone know? Okay. So as of now, understand what is the data?
Yes, I.
Okay. Yeah. Means it is a raw data, we call it, and it is unfiltered data also, we can call it, or we can call it unfiltered and all. So if what is our role is, our responsibilities is, we can make it this data into useful. It means information, because all the data is not necessary. All the data is not useful and not readable also. Like suppose as I mentioned before, like 12 or something like blue or something, bike, or this is, there is no relation between these. Information is structured. Information is what we can process data. It means like filtered data. Suppose if with these data we can write someone's, like suppose I can say his age is 12, then that is meaningful. His shirt color is blue. It is a, for some of information it is useful. He likes bike. That is one sentence. It is the information. So data is different form of data we have. Information we are need to be get that from using data. We can get information. So with the information, what is the useful with the information means, so companies need this data, and after this data is collecting, they can transform it to the information. With the information, they can derive it from insights. Because of that, this is the process happened. Everything like data. So Can anyone tell me how many types of data? If you know, it's better. If not, I will tell you.
Yeah, Sai, I have one doubt. See, so if in cloud or in hard drive anywhere, we can't store any directly information in the any storage. But we will store data as a document, data as an item. So we will store as a item or item level item or as a document only, right? Directly data, direct information we can't store anywhere, right? But
We can store.
our job, data engineer job is to store the data and retrieve the data. But we can't retrieve the information. We can't retrieve the data. Nothing but some collection of content, some collection of documents, collection of items only, right?
Correct.
But
So
information we can't flick the information. We can't store the see user only store the information. But our job will be the we can store the collection of items. We can store the collection of documents only, right?
no.
See,
We can do collection of raw data. So with the raw data, we are making it to the meaningful. We can use different types of transformation to making it useful information.
okay.
There are, see, people are sending all the logs or something. They have whatever they have data, they can push it. So from our end, we can apply some filters and
Mhm.
make it some transformations and it making as a structured way. So it is in the form of rows and columns or in the form of particular data format.
Mhm.
Like different types of format we have, accordingly it will be useful, like information. With that format, companies will getting insights, business
Mhm.
insights. If with the data they can't get it because data is huge. Only they want in my primary screen you can observe this filter. This will be like a data will come like this, but ultimately we will get only required information, not all the data, because it will be mostly information itself having lot of cost. um, we can save and all. If you can do all the data insights, it will be large and it is not useful also. That's the thing. So we will continue, we will tell you how we can do, what are the transfer. It is the subject, right? That is the part of Azure Data Engineering course. You will get all the details once you can going in the forward. Okay,
Okay.
this is a
Yeah.
basic. I'm saying collection of facts or collection of info, collection of data is uh, this is the basics. Okay,
Okay. Okay. Sai, one more doubt, Sai. Okay, sorry to interrupt. Okay, so you tell before the start class only you told right. So from raw data to cloud inside. So how many data is the data types are there? So but what is the exact raw data?
I will
Uh,
tell.
to,
I
to
will tell.
understand
I
easy.
will tell. That is what I am asking. Types of
Yeah.
data.
Yeah.
There are different types of data we have. One is structured, structured data. Okay, we have structured data. It means it is coming like a rows and columns. Okay, you know, many of know Excel example, and yeah, it is structured. It is in the form of rows and columns. It is one type of organized in tabular format with predefined schema. I mean, this is a column, this is a row. This column is with numeric values. This column is alphanumerical. This value is characters only. So this is a structured format. So without we cannot push another data. So this is one of the format of data. You are asking raw data, right? This is one of the form of raw data, structured. Then we can say an example also. You can say you can go Amazon portal and you buy something. You will see like order ID, product, price, timestamp, customer ID. These all the details we can call it as a structured data. Okay.
Yeah. Understand.
Yeah. Now the second type is semi-structured data. Semi-structured data is nothing but it is like not purely structured and not like unstructured. It is like semi-structured means in the form of key and value pair. It means the information which is having like message or you can use mobile app. It will be like a message, user ID, something, location. We can put it like that. And easiest way to understand is many people know logs. So logs are there in the semi-structured data. It is called it like semi-structured data. It is huge. Logs are huge. We no need to, like, we don't need that much of data. Only we require some information in the logs. So it is like it will come huge amount of data. So this is called one type of, like, it will be like such coming like in between parentheses and all. We can take an example, log data. So the third one is unstructured. This one most of the people know unstructured, because in daily right now, I mean, in the media, I mean, everything is in the social media. It is called unstructured data. You can take an example, Twitter, everything is unstructured. Images, videos, or documents, everything is unstructured. There is no structure on it. So images, audio, video, everything. So these three types of data is there, like structured, semi-structured, unstructured. So anyone have any questions on these types of data?
No, Sai.
Okay. Thanks. Thank you. Please let me know if any have any doubts. Please interact. So I will tell you more clarity if you have any doubts. And we will going sections also like this. And each topic we can go with clear understanding for everyone who was there. Because without understanding the topics will go on, it will be problem again. So please let me know if you have any doubts. Okay. Yeah. Next, this is types of data I covered. Example in the data, I showed this is the data, and this is the information. Processed data or filtered data or contextualized data. So this is one of the example I'm saying. Just different types of data covered: structured data, semi-structured data, unstructured data. You can call it data organized as tabular format, and key value pair format, semi-structured, and this is images and video and all. Then we can go with the evolution of data from physical to digital. So many of you know, in the before this evolution of computer and all, everyone may know. I think few people are born later 2000, maybe don't know, but many of know that banks or any government organizations maintain ledgers. It is form of rows and columns. So they can write it in the everything in the that book, lecture book. So that is initially happened. Later we have in the time of 2000 and all, we have RDBMS. So in the RDBMS is nothing but a relational database management system. It is store the data in the form of structured way, like this, rows and columns. So later 2000 and all, data is day by day increasing. When exactly, tell me someone how data is big now, why it is? Can anyone tell me your idea from when it is starting going big? Please be guys interactive. And yeah, so everyone knows internet going to be huge, and internet will be getting very cheap, then the data will be going huge. That will happen last 2 decades. So it is increasing, and nowadays it's all about social media. It is everywhere, it is data. You can say an example, social media, IoT or online services, huge volume unstructured and real-time data. So that this will happen, evolution of physical to digital. Now everything is digital. Earlier it is everything making in the nodes and all. Now everything in the save it in cloud as well. On premise means in the form of physical server build and storing by everything is there. In previously companies will handle like that, but now everything like taking rental purpose for using cloud and all. So this data evolution is from physical to digital is happened like last 2.5 decades. It's a huge, now it is like a petabytes and exabytes. That much of content is generated daily, not like a month or week or something. Daily it is generated like petabytes, exabyte. Every company like that storing the data, that much of use. So we understand why companies need this data. Okay, we are talking about data, different types of data, and data generated from physical to digital. Everything is done fine, but why companies need the data? That is important, right? They are getting this much of amount, put this much of amount to store the data. Why? Because they can store data, and they can use the data, and they can use, because of the data they can take decision makings. Suppose in particular location people like something, how can get them to know? So they can implement surveys, they can taking business insight, like where this product is going, huge market. So they will get the details, and they can send more products to that place. If somewhere it is not working out, why it is not working out, what is the reason, and how we can put to working. So they can put some offers and all. So they, anything they can take decisions because of that information which is they get. So because of that they improved efficiency, then they can, business will grow. So understand the customer priorities, they can understand the customer priorities because of this data. And with these, all these things, they will drive, I mean they will go their business to the growth. Without data they simply something they can run the business, they just use it. They don't know where the products are required, their products are required, where their products are not required. So it will be clumsy total. So companies need feedbacks, companies need information. Any you can take any company, because of this data they are saving and using to improve their business. With everything, every day they can analyze the business, why it is down, why it is up, where it is down, where it is up, everything. That is required for any company to grow fast, especially for fast. So that is because of these reasons data is must and should for any company. So in the span of like 2015 around, because of internet cheap, many companies telecom companies arise, and the internet going very cheap in the time of 2015. Everyone saving data, so that is huge. So that is called big data. So big data is nothing but a problem. What is the problem with big data? It is volume, huge volume of data. As I said before, it is a petabytes, exabyte is generated. How to handle this much of data? That is one problem. And then variety. We have different types of variety of data. So how we can store this type of some structured data? Okay, we can use RDBMS. Unstructured data we can save it, and we can use semi-structured data. So where we can save this type of data, different data. Then velocity. Velocity means you can see high speed. Everyone requires high speed. So now you can example I'm saying for velocity, like stock market. So you know, right, how it is, stock market is going on, like gaming also same. So these are the challenges with big data. How we are handling this much of uh, data, and speed, and processing. So that is the problem arises. You can see big data challenges, storage, processing, cost, because data saving is not an easy thing. You need to buy servers, you need to buy storage, and you need to maintain data centers. Everything is costly. So complexity and skills also required. Big data has to handle, there is lot of technology skills are required to handle it. So these are the challenges with the big data we are seeing. What is the solution? What is the solution for early solution? It is called a Hadoop. It is Hadoop is nothing but on premise, we call it as. Azure, AWS, and Google, these are the cloud platforms. Hadoop is a earlier solution in the time of big data. So it is an on-premise, we call it. As I said before, there are a lot of technical skill is required to handle big data. See, HDFS, HBase, MapReduce, Yarn, Hive, Pig. These are the different technologies required to understand and implement because to handle this much of data. Early it is why it is solution means it is a open source. I mean it's a free to access anyone, so it is easy. But the problem with the Hadoop is you need to set up data centers, hardware, software, everything you need to be maintained. That is huge burden. Then how the data is stored in Hadoop is HDFS, we call it Hadoop Distribution File System. A distributed file system designed to store very large files. That is the basic, that is the, because of that is the reason Hadoop arrives, and it gives some solution to the big data storing. MapRoute is nothing but processing. Once the storage is fine, then we need to process the data. We can apply transformations and all. Processing also required very fast. MapReduce came. Yarn is nothing but a resource manager. It will be like master slave architecture. If something request is coming, the Yarn will analyze and sending the request to the different nodes. Nodes is nothing but our mission. One computer is called node. So this will happen from Yarn. Then Spark arrives. Spark is nothing but it is very quick compared to MapReduce, like 100 times faster. We are also using in the cloud integrated with Azure. So I can tell you later about Spark. So this is somehow solutions are coming with Hadoop, but lot of challenges happen because of different. I can tell you, like scalability in the cloud. Cloud arises for data. So what went wrong with the Hadoop? It will be solution in the cloud. Scalability in the Hadoop, we cannot increase the suddenly. We cannot increase the missions or store the data and all because it's a on-premise. We need to buy the servers and we can place it and all. It will take time. But in the online, in the cloud, it is nothing but working like a pay-as-you-go model. Whatever the infrastructure, everything will be provided by Azure or AWS or Google. That is handled by cloud. We just sign up to the Azure and taking pay-as-you-go model. Whatever we can use, we can pay rent. That's it. So scalable means we can increase the systems. Whenever the data is coming, we can increase. Whenever the required, it is increased. The time of sometimes business is very huge. At that time, we can increase automatically. Otherwise, it will be reduced again. That is called scalability. It will not happen in the Hadoop ecosystem. Then cost effective. We no need to buy everything. We just taking a rent. Whenever we require, we can take it. Otherwise, we can again shut down. So that will be huge cost effective compared to Hadoop. Cloud will be provided. Managed infrastructure. We no need to manage our infrastructure. We no need to taking care of data centers and all. It will be taken care by cloud providers like Azure, AWS or Google. So we are also integrated with cloud, also integrated with big data tools like Hadoop, HDFS. I said same pattern we can use it in Azure. Call it ADLS. Azure Data Lake Storage. So and Spark, as I said, Spark also be integrated in big data tools like. So it is accessibility also global. If you have username and password, you can able to access it in anywhere from anywhere. So that is flexibility with the cloud, not with the Hadoop ecosystem. So real-time process. This is a huge in cloud because Hadoop there is no real-time. Only batch we can call it. I can explain a little more in the coming sessions. But right now, real time means, as I said before, stock market, and you can taking any real time businesses. It is handling by cloud very quickly and effectively. So these are the overcomes from Hadoop to cloud. It is a game changer. We can call it as cloud is a game changer for big data. So I can go with this architecture. It is a sample architecture for data architecture for Azure. You don't need to worry. I will go everything and with the detail every topic I will explain very slowly and understandable. Here I just go with what are the topics there in Azure to handle things. I will tell you. First, we have multiple sources. We can put different sources like on-premise systems or cloud, different applications. We are getting data from different sources. We can implement process. We are implementing some filters or we can implement transformations and all. Then we can store in client's requirement. We can store in databases, SQL database, Azure SQL database, or we can Synapse analytics. So we can place it once it is transformed. So in the transformation also we have different layers. Call it like bronze, silver, and gold. This is called like medallion architecture. We can cover it later. But coming to the topics, ingestion. For the ingestion process, we have tool like ADF. In Azure, we have Azure Data Factory. It is like we no need to write any code here. Everything is there in drop and pick, drop and drop, like drag and drop. Like no need to go coding and all. Simply we can everything will be there. I will show you tomorrow in the session. Open Azure and I can show you what are the options out there. It is very easy to drag and drop. Every transformation also do the same thing. No coding here required. And Events Hub is real-time data we are using, and Stream Analytics also same. And storing, we have two types of storing. One is Azure SQL database and ADLS, Azure Data Lake Storage. This is integrated with the Hadoop, like HDFS, Hadoop distribution file system. Background, it will taking like that to store the data. And processing analytics, we have here processing, data processing, we have two types. One is Azure Data Factory, we can use we are no coding, low coding method, and Azure Databricks. Here people are using like notebooks where they can write code and get it done. So, but many companies right now working with Azure Data Factory, because Azure Databricks compared to Azure Databricks is huge. Amount wise it is huge, need to pay. So many companies still using Azure Data Factory. That is that is very helpful to the people who are not coming from coding background. The people who are coming from coding background, they can go with Databricks. But as per the company's requirement, also important. So then all transformations and everything is done. Then it is Power BI. Power BI is not part of our job. I'm just placing it because to understand why these transformations are. Then Power BI. Power BI will be generated dashboards and insights. As I said, insights. The business people will join the calls with these Power BI engineers and they can get insights from there. These Power BI engineers will get data from our end. So our we are upstream from Power BI team. So this is a sample architecture. Simplified, I'm going to here. This is a source. We can take it. The API is one of the source. And using Azure Data Factory, we are moving data from API to raw layer. All the data. It is called raw data. Then we are implemented some filters and all. That is transformations. We can place it in ingestion layer. From here, the people Power BI or ML engineers or data scientists will come and implement some more transformations as per their requirement. They can place it in presentation layer. Once the data is there in presentation layer, it means the data is ready to showcase to the end users like clients. That is means presentation layer. And this is all the call, it is orchestrate. Everything is orchestrate and ingest, transform, and analyze. This is the presentation layer is for analyze the data. Okay, this is a simple way of things. I'm going to then, yeah, that is about Azure Data Engineering. If you have any doubts, let me know. I will go next this pattern, but before that, you just let me know if you have guys any doubts on anywhere. Atar, Raja.
Yeah, fine, Sai.
You understand, right? Okay, great.
Yeah, yeah.
Atar is fine, Atar?
Yeah, it's fine.
Okay, great.
No issue.
Yeah, now everyone is looking for why this course is required, what is the future of data engineering. So I can say in data, there are different types of roles are there. their salary comparison also I'm giving here. So see, data engineer one role, data analyst, data scientist, data architect. Apart from these, ML engineers also there, ML AI engineers, everything. But these are the main data roles. And data engineer, we can do transformations, raw data, moving to the transformations and all. Data analyst, using the transformed data and presentation to the clients, that is data analyst. And data scientist will apply some modules, machine learning modules and all, to like more analyzing part, like predictions also they can do in the future predictions. So architect is nothing but handle everything. He can take the projects and he can assign the tasks to the data engineer analyst, and what is the requirement. He always touch with the clients. He can get the details from the client, and he can explain to the different teams, development teams and all, and completing the work. That is the architect level. So you can see the packages also. And data engineering starting roles, how much, and middle and the senior level. So these are the sample, and I mentioned, but in the real market it is huge different. If you are having well skilled, and you will get more than this. This is the average I'm saying here, because nowadays market is used for data engineering. You will get more than this if you have real experience, like what it is basically interview, how you are cracking the interviews. Whenever you are practicing everything, you will crack the interviews, and you will get more than this what I mentioned here. This is for sample average salaries I'm giving. And next, why Azure wins in data compared to other clouds. Like, you guys can think why Azure only, like Google also there, AWS also. See, in the cloud market, AWS entered first in 2008 somewhere. Cloud in Azure, like Microsoft comes later. But now it is rapidly growing. Microsoft is rapidly growing all over. Compared to AWS, now market is growing very fast for Microsoft. Google is third place. So data perspective, Microsoft is first, because his market is very huge world around. It is there, like data centers also compared to AWS. They can provide a lot of data centers for users. And uh, the companies, the top 500 companies, or most of the companies using Azure and Microsoft products. And in like Microsoft is coming cloud is very late, but AI and data adoption wise, Microsoft is the first place in AI and data adoptions things. Whatever the data related things are in the market, it is very quickly adopting. Like Databricks also, it is compared to other clouds, Microsoft is adopted very quickly and effectively. So technical and cost also, it is very, compared to other things, Microsoft is very less. Will get the options, like two ways will provide Microsoft options. If you can provide cost, they will provide that much of services. And if your company is not that much of efforts, they will provide services accordingly. So two ways they can provide, but solution will be there with the Microsoft. That is the main reason Microsoft is growing daily, and compared to other clouds. So now we have multiple clouds, Azure, AWS and Google. Apart from that, IBM is there, Alibaba is there. Those are very less market. And because of this, Azure data engineering going great, and companies also wanting the engineers. See, Azure data engineering future job market. So it, as I said before, it's a massive cloud adoption, and big data, real-time analytics integrated, and AI and Copilot tools are integrated, and notebooks, as I said, in the Databricks we use notebooks. Copilot integrated with the notebooks itself. So and more, there is a lot of openings are there, but engineers are less. That is the huge market. Because of that, it is a huge market. Every day you can go and search in Naukri or LinkedIn. How many jobs are open for data engineering, especially for Azure? You can see a lot of jobs are there. Accordingly, packages also there. And versatile career paths. I mean, once you enter into the data field, you can next level, like after you are completing your data engineering, completing 2 to 3 years, then you can go with data scientist or ML engineer or architect level. So there are a lot of versatile paths are there with the data. So these are all advantages with Azure and data engineering field, and you can decide your path how it is going. I mean, it is a rapidly growing, and your career also will be changing hugely. This is the right time to shift if anyone wants to shift their career and they can stuck in somewhere they want to move. This is the right time. And yeah, that's it from my end. Kindly let me know any questions or doubts. Now it's your turn.